Tonight we have a talk from Conor Smith, Head of Engineering of thejournal.ie, and he's here tonight to talk about building a PHP app from scratch. Personally, I'm really looking forward to this talk. So without further ado, let's welcome. Okay. Thanks,
Thanks, Barry. So I sort of assumed I'd have like a lectern or something to hide all these notes behind, so sorry. So as Barry said, I'm Conor Smith, and I'm going to talk to you for far too long about building a PHP app from scratch. I'm the head of engineering for Journal Media, and we publish thejournal.ie, the 42, the Daily Edge, and Fora. And we are hiring senior PHP developers at the moment, so if you're into what this talk will be about, automated testing, the occasional little bit of rescuing legacy code, then talk to me afterwards. So I like tomato sauce, which I know it's quite a gambit, but I like tomato sauce. It's hearty, it is versatile, and it's really fucking delicious. And it's also a metaphor that I'm going to drive into the ground. So if I go out and I buy a frozen lasagna or I order in pizza, there's tomato sauce in there, and it's good. And that is the equivalent of using software. If I'm going to make dinner at home, then I'm going to use maybe a jar Dolmio, and that, in this metaphor, is writing software with a framework. What I like to do is make my own tomato sauce from scratch, which is the metaphor for this talk. So when you're making tomato sauce from scratch, you pick up some tricks once you do it enough. Like if you put in a tablespoon of tomato paste, you can simmer the thing for 1 hour and it'll taste like you've been simmering it for 4 hours. You can also make the tomato sauce exactly to your liking. So if you like a spicy meatball, you can throw in some chilies, you can throw in a bit of cayenne pepper, and the thing's going to blow your mouth off. The important thing is, when you make enough tomato sauce, you're going to understand why you were doing things the recipe was telling you to do in the first place. And when you understand why, you can start to make really specific changes that maybe you haven't heard about before. So that's why I add vodka to my tomato sauce. So you see recipes telling you to put wine in tomato sauce, and so one of the reasons is it's going to give a fruity flavor to the tomato sauce. The second thing it's going to do, though, is tomatoes contain certain molecules that are only soluble in alcohol rather than water or fat. So if you don't have alcohol in your sauce, you're not going to taste that part of the tomato. I don't like to cook with wine. I'll open a bottle of wine, put a little bit in a sauce, and then waste the rest of the bottle. I have vodka lying around because I hate vodka as well, but I can just throw that in instead. I get all of the advantage of the alcohol flavor without all the disadvantage of the wine. I never would have figured out how to do that if I wasn't doing this from scratch. I wasn't going to just know that buying Dolmio off the shelf. So if you wish to make tomato sauce from scratch, you must first create the universe. I said that.
Wise.
So when I say I make tomato sauce from scratch, I'm not growing tomatoes. I'm buying tins of tomatoes and opening them. I am not growing basil. I'm buying basil leaves. I'm not making a pot in a forge. I have a saucepan. Similarly, when I'm making an app from scratch, I'm not writing all the code myself. I am, well, first of all, it's running in PHP. I did not write any of that. And I'm using third-party components to do all the heavy lifting for me. I'm really just writing the glue to hold it together and to execute the actual important business logic. So in this talk, I'm going to go step through building a whole PHP application without a framework. I'm going to focus on the decisions that I make at each step as the application grows and how I structure it and how it's interacting with the third-party packages that I'm using. There's one warning before I start. I am not writing any tests. I won't be showing any tests. This application that is up on GitHub doesn't have any tests. It should. If it was used for anything other than the purpose of this talk, I would be writing automated tests for it. The application I'm going to build is the PHP Dublin monitor. a website that lets you know if the PHP Dublin website is online. Now, I don't know who needs to do this where they can't just check the PHP Dublin website, but we'll pretend that we were told that we had to build this and we don't get to argue against it. So the requirements are we need a public-facing website. It's going to tell the public whether it's on or off. We're going to need something that's going to be polling the PHP Dublin website to actually see if it's on or off and store that status to be accessed by our website. And probably going to want to throw in some sort of administrative function to see, you know, why it's down. Is there something wrong with the tool or the actual PHP Dublin website? The code, as I said, is up on GitHub if you want to look at it. It might be hard to follow along during the talk, though. So, to start with, I have a composer JSON file. It's how I always start every application I write. The name of the application in the file, I just use my repo name from GitHub, and then I set up an auto-loaded source directory, again using the same name as the base namespace, and having kind of this namespacing on the whole app will prevent any problems down the line where maybe I actually need to import one app into another for some reason, and it'll make sure I didn't just call something a generic name like database connection and now not be able to use it because I already have one of them. When I run Composer Update after creating this file, it's going to generate a vendor directory for me. It's going to have my very important autoloader file in there, which is going to save me a lot of trouble. There's no packages, but it will still create the vendor directory for me and that file. I got a git ignore set up immediately to not include that vendor directory in version control. We should not put the vendor directory in version control. It's not our code. There's no point. It's a waste of space. There's a lot of reasons. But I do put the composer lock file in version control because this is an application that we control. We want to make sure all the versions of it, people developing it, everywhere it's run, that everyone is using the exact same versions of the dependencies. It's not like putting out a third-party package where you want to give users of it flexibility to use different versions of its dependencies. You just set them. It means everyone's running the same thing. You're not going to get it works on my machine, it doesn't work on my machine problems, and other issues like that. The entry point to the application is the file that you're going to execute. It's going to be the first line of your code that runs. I meant to say this is all written in PHP 7.1, so there's a lot of declare strict types around, there's a lot of return types and stuff like that. So I create this console file because I'm going to write a CLI entry point, and I require a bootstrap file, which is right here. The bootstrap file is where you would set up your application. Its name comes from the lifting yourself up by your bootstraps idea. The application starts itself in here. Now, we don't really have an application yet, so all it'll do is include the autoloader. And I thought I'd mention that the dir magic constant is a lifesaver, because I went a long time without knowing about this, but basically, it just evaluates in whatever file it is to the path of the file, which means if I had left it out here and included this, it would always be relative to the executing file rather than this file itself. And you get into relative file hell very easily if you don't use dir. But we want to actually start doing something with this code, so I'm going to create a kernel. That kernel is going to wrap Symfony's console application kernel, because I don't want to know about how the low-level stuff with the CLI works. Symfony dealt with this for me. So I use Composer to get that. I create a new instance of it in my kernel class, the first class I've written for this application, throw it in a console namespace. And then in my console entry point class, I just create a new instance of it and call the method it has. I can create the instance because Bootstrap has the autoloader in it and everything is sorted for me thanks to Composer. And now the app actually does something. I can run that console and I get the default help menu for the Symfony console component, which isn't useful, but it is something. This just means that all that code I wrote is running the way I thought it would, so I'm happy. If we look at the directory structure of the application at this point, we can see our source directory has our one class, and we have 5 little classes, or 5 little files rather, in the root, including our auto-generated lock. And then the vendor directory is full of classes. Don't need to look in there. That is going to have the most code in this application now, and it probably will always have more code than the rest of the application, and you should be happy about that. One problem I noticed already with this code is that I've been creating objects in different places. The kernel, as I wrote it originally, had the Symfony kernel created in it, and the kernel itself was created in the console class. So I want to keep all that creation together, because object creation is very tricky. The Gang of 4 book has 5 different patterns about object creation out of the 20 or so in there. It's not trivial. So what I do is I extract the creation of the Symfony application out into console, and I inject it into the kernel. So the kernel now depends on the Symfony application, which means that it's a dependency, and I am injecting it. So this is dependency injection. This is all that dependency injection is. I am taking a thing and putting it in here and then using it in here. You can do this in the constructor, you can do this in setters, you can do this in public properties that you can change, just as long as you get it into the class. I use the constructor because I don't want this class to do anything without the dependent application. It can't do anything. Like, it does one thing, it calls run on it. So if it's not in the constructor, the object shouldn't exist without that class. So on the road to getting this application to actually do things, I'm going to keep putting all my weight on Symfony here. I'm going to use their command class as part of that console application to let me just build out a little command. So all I got to do is set a name, optional description, and this execute method here is where I put the actual logic. I'm just going to have it output placeholder text for the time being. Back into the console class, we got to actually create this new action we just created. That needs to be injected into the Symfony application. That happens to use setter injection rather than in the constructor, so I gotta extract a variable and then use call the add and put it in and then add it in here. And it's all getting a bit messy in my console, but we'll get back to that. I can call this specific command now, log status, and it'll give me my placeholder text, so it seems to still work, that's good. But creating all of those objects in the entry point is getting out of hand. It was very difficult. It is very difficult to see what's going on, especially with the fully qualified namespace and everything. So I'm going to use an inversion to control container to isolate all of my object creation in one place, have them registered in a single object, and have the concern of object creation away from the actual behavior of those objects. So I create an application class. In that class, I have used Composer to get Laravel's IOC container because it's got some handy little features on it. Throw that in the constructor, and I add this make function to make that allow anything that has access to the application object to make stuff that's been registered in the container. The register services method is where all the creation is going to go for the time being. So we take the Symfony kernel, my kernel, and the command, or the action rather, and put it all in here, no longer in the entry point console. And when I go back out to console to fix that, I go into the bootstrap and actually finally create an application in the bootstrap. This file will return the application, meaning that in my console I can require it and then just put it right into a variable application. I can call that make function, make my console, still fully qualified, but it's just one, so it's still pretty readable. And I got my kernel, and I can call the handle method on it. Just back to this for a moment, actually. The the function here is an anonymous function that's not going to get executed until something in the code actually tries to call this kernel out of the container. So don't get worried about it if you think you're doing a lot of creation at the start. It's not actually happening. So I said that this is going to be the part of the code that's checking the PHP Dublin website, and we're going to want to actually store the status somewhere. So I've opted for a MySQL database. I've installed Doctrine's database abstraction layer because I like it. It's pretty powerful. It does a few extra things you can't do with PDO by itself. And then I inject that into my action. And now I can make my execute method do something other than write out placeholder text. I have it insert nonsense data into a database table that doesn't exist, but it's something. When we go back to registering the service, I now have to create a new container entry for the action that'll insert the database. Now I said I had to. I actually don't have to. I opted to. I've replaced the action in the kernel. It was creating a new here, and I could have created the database connection in here, but again, this whole thing would have started to get a bit overwhelming. So I've separated it out into its own registry. And I connected a database here. What I don't want to be doing is adding sensitive credentials to version control. So I'm going to use environment variables instead, use PHP's native getEnv method to call the environment variables. So that means any security concerns of someone searching GitHub for DB passwords isn't going to affect this. And it also means that we can run this application as it is on any stage without having to change the application code. I can run it locally, I can run it in continuous integration environments, I can run a staging and production environment. And as long as I've got outside the application the environment variables set correctly, then it's going to work. Of course, setting up environment variables locally can be a bit of a pain in the hole. Especially if you have to change them frequently, or if you're using them a lot and adding new ones, refactoring them in some way, making sure that they're still there on system reboot as well. That can just be a huge thing. So I've installed the php.env library to help out. To use it, I create these two .env files in the root of the project. One of them has the credentials, one of them is an example that's empty. One of them isn't getting added to version control. To use the library, you have to actually call it somewhere. So I go back into my application, and I put a little redirection in here in the constructor. So now I have this boot method. So when the application is created, it boots itself. Boot creates an instance of .env, which tells itself where to get the .env file, and it loads it. And then we go back to the register services function, which was originally in here. You want to try and load this as early as possible in the application, because if I had something up here trying to access an environment variable, it's not going to work. One thing to be careful of with .env is it's not built for production use. I haven't bothered putting anything around it here. This is reading a file on every single execution of the application. You don't want to have that in production. It's going to cause a lot of slowdown. You can just check if the environment variables have already been set by something else, and then not call this if you're in a production environment. So if we tried to run the application right now, it would be completely fucking broken because it's trying to write to a database table that doesn't exist. So we've got to create that table. And I could just go in like MySQL client and just create it there pretty easy. But then if I give this code to someone else, they're not going to know that. I could copy and paste that thing I just put into the MySQL client and put that in somewhere, maybe Google Docs, or I don't know. Or I could just make it part of the code of the application so it's all handled automatically. And that's why I installed a library called Finks. That's more of a tool and application and a library. It kind of runs alongside my application. This is the config file for it, which is a bit of a pain. because Fink's sidebar is sort of designed to have the database credentials put into version control in multiple different stages. I don't understand why, but I found this workaround anyway by using a PHP-based configuration for it, loading in my .env, loading in my autoloader. The important part is I didn't put my password in GitHub. And this looks like it's sort of another entry point to the application. You know, I'm calling the autoloader, I'm loading up environment variables, but it's not. Maybe an argument could be made that it is, but I'm just saying it's not. It's configuration for a almost totally separate application, a sub-application of my application. So, no. This is what a migration looks like in Finks. These dots represent a timestamp. That would have taken up too much space on the side. This is namespaced. I'm setting it in a completely different directory. It's outside of my application source code. The only thing that's ever going to call this code is Finks. And it's just going to create a table, give it this online column, and once I run that, then my console should be able to run in the environment and stop throwing errors. So I've got a working application again. I want to give it a little more functionality. I want to record the time that the status of the PHP Dublin website was logged at alongside the flag of whether it's up or down. And I installed a clock to do this. And this may seem like overkill, but it's not. It's this thing called Chrono. I inject a clock interface into my action. Then when I'm inserting into the database, here's my new column I want to have, and I'll take the current time at UTC, format it for MySQL, whatever. The reason I'm doing this is because if I has written a test and just used PHP's internal date function here, that test isn't going to run that test isn't going to pass every time it runs. I'm going to have to be, well, calling the same PHP date function in the test and then hoping that the test code and my application code both executed in the same second, because if there's a second difference, the test it's just going to fail. If I'm recording microseconds, I'm never going to get it to work. By abstracting out time out of here, by decoupling time from my action, it means I can just put a fake clock in here that will always return a known value, and my test will know what that value is, and I'll be able to check it. We need to create another migration because we just created a column there, so second migration. Also going to add that new dependency into the registration of the action, and it was looking for a clock interface, and I'm passing it in a system clock. This library has a few other clocks, test ones, and there was more, but I'm not sure what they were supposed to be. I didn't really look. Checking in the application now, we can run the console command, and it tells us that our dummy data has been inserted, which basically just means that the app didn't fail running. I have to check the database to be sure that it got in there. So there, yeah, online, time it was logged at. And then there's this ID column that I don't remember telling the application that it should have. That's because Finks, by default, adds an auto-incrementing ID to every table you create unless you explicitly tell it not to do that. And that's why you always read the fucking manual. This is what our directory structure looks like now. We've got our database migrations folders up here, got a few more classes in our source, and a bunch more config type files in the root of our application. So something still feels wrong. Every time I've been adding a new class, creating a new class, or changing the dependencies of a class, I've been editing the application, which probably shouldn't change that often. So I'm going to introduce the concept of service providers. They will isolate the actual registration into the container into separate standalone classes. So instead of the application registering services, it now registers service providers. And I just create my service provider, call the register method, and of course give it the container so it can actually access it. This is what the service provider looks like, one function. And I've copied all my old logic from application into this register function. The app still has the exact same behavior as it did a minute ago, but now the structure is substantially improved. So these are the use statements on my console action right now. And they can be divided into two categories. We've got these Symfony classes that are in charge of the command line interface, and we have the database and the clock stuff, which is related to more low-level infrastructure concerns. So what I'm going to do is I'm going to extract a command object from this action object. This is the command. Looks familiar, right? It's the database, the clock, inserting in, all that stuff, exactly the same. I literally copied and pasted it. But the important thing that you might notice is that there's no reference at all to console, to CLI. There's no functionality. There's no language of the command line in here. This is completely agnostic to how it's called. This could be called by a web page. This could be called by some other way you run PHP. We go back to our action. It now depends just on the log website status command, but that's all it knows. It knows it has to call a command. It doesn't know what that command does. Yes, this command I moved out of the console namespace as well and down into the base namespace of the application. And I'm going to need to create a new service provider to have the creation logic for that command. So as well as the console service provider, now the application will also register a nothing service provider, a base service provider. And we're inserting the database connection and the system clock like we had been in the action in here. And what you would see if I had the code up for this is that I have now completely removed the registration of the console action. The only dependency the console action has right now is this. And the Laravel IOC container uses auto wiring. So that means that it can automatically determine what dependencies to inject if possible. This dependency is completely set up here. The container knows how to build it. It's the only dependency of the action. So anytime I try and create that action from the container, it can create it here without having to have been explicitly set up. It is very handy for saving on boilerplate code. So this actually needs to talk to the PHP Dublin website at some stage and see if it's up or not. So I install Guzzle because it's Guzzle. I've set the base URI in the configuration of Guzzle to the PHP Dublin domain name. I'm setting it here because it means that I can continue to run automated tests on my command that won't be making real calls to a real website. I can put in a fake Guzzle, I can put in a real Guzzle with a different base URI, whatever I want. I also set HTTP errors to false, which means Guzzle won't throw exceptions if it gets a 400 or a 500 error, because that is not an exceptional circumstance in a tool trying to see if a website is online. That is, we want it to keep running. So I modified the command. It makes a request to the base path. There's the response. Get the response, or get the status code from the response if it's 200 online. If it's not 200, not online. I don't like having magic numbers in my code though, so I installed this library called Teapot, which just gives human readable status codes for all the HTTP status codes. So now instead of 200, we have status code OK. So it's a little bit of ambiguity gone there. Just checking the status code is a bit of a naive way of seeing if a website's online or not. Could be badly configured and just returning a blank page, but it'll do for this. So that's the command line part of this done. We run the command. It tells us, oh, PHP Dublin website status was logged. We can go in the database and check that it actually did it. This is our directory structure. It's got the same migrations few more classes in our source directory now. We have kind of 2 distinct levels, each with their own service provider, and all of the code in this console one is exclusively dealing with the command line, and the code outside doesn't really know about that. So we finally get to add another entry point to the app other than console. Public directory, create an index.php file, and have it echo out placeholder text. Spend probably too long getting your web server to actually serve this up properly. But when you see this, you know that this code's running right, and you have a second entry point. So let's get the application in. Same bootstrap file that console uses. Get an instance of the application booted up. Make something. So we're going to make this, this action, and then we're just going to invoke it. So this is what our action looks like. Placeholder text should look exactly like this. To do something a little more complicated, let's throw a DB in here. We'll just select the latest status, and we'll print out whether it's online or offline using a nice little formatted print function. So actually, I meant to mention that action is in a web namespace as opposed to the root one or console. And we almost immediately now have to create a third service provider in the web namespace. And it passes in the connection to database, same environment variables. Should look very familiar. And then, of course, make sure that that service provider is called by the application when it boots. And this is a working PHP Dublin monitor website, but we can keep going. So you may have noticed that 2 of those service providers both create database connections. And if I'm not careful, I'm going to create more and more database connections. Every time that's called, it's going to create a new instance. My application, if a loop was involved, could start hogging up resources, kill the whole machine, and take a website down. And then there's no monitor for this monitor, so we wouldn't even know. So instead, I extract the creation of the database connection to its own registration in the container. The Laravel container has a singleton function you can call that'll make sure that this code's only executed once. This connection is created once and stored in the container. The action, or the command here rather, is just going to get an instant, the same instance of this that, no, that's wrong, that the web action will get. And that means it's going to prevent heartbreak in the future. That sprintf function I had in the action originally isn't going to do much. If we want to have a full, website with HTML and stuff, we're probably going to have templates. We're going to want to render full templates. So I installed a package called Plates, which is designed for rendering PHP-based templates as opposed to like an arbitrary one like Twig, or for some reason I can only think of Twig. Anyway. So I inject that engine in here, and I tell it, hey, render this home template, and pass it a bit of data. We'll call it status, and there. In service provider, of course, got to set up the engine, so just got to tell it where I've put my templates. I create a resources/templates directory, and I put a template in there called home, and it knows how to find it. And there's a status echoed out, and it looks pretty now, because I was able to put as much HTML as I wanted in that template. I connected to Bootstrap CDN and got some nice CSS going. While I'm at it, I also want to add a last updated field to the website, just so you know it's not out of date. 8th of December isn't that long ago. So from the database row, I create a datetime object, pass that into template, let the template decide what format it'll come out in. Don't need to set it all up in the action itself. Most websites have more than one page, so that means we're going to have to set up routing. And I'm going to start by installing 2 packages at once, the PHP League's root package and Zen's I'm going to say Diactoros. It's some ancient god. I've never said that word out loud before. Diactoros is an implementation of the PHP SR7 HTTP message interface standard, which will be useful later on. So I create a new kernel in web, similar to the concept behind my console kernel. It's really just kind of wrapping up the roots collection that gets passed in. I pass it in an instance of the request that's come in from the web server, and I pass it in a blank response because it needs one of those. And then I can define a route for my existing action. So at the base, at index.php, effectively, execute this action. I do need to modify my action a little bit to work. It was returning nothing. It was taking in nothing. Now it needs to take in a request and a response and return a response to work properly with the routing library. Up to this point, the output from the action was just being echoed. And now we're after setting up this whole request response thing. We should probably put that string into a response and send it back somehow. So I use an emitter, part of the Zend Diactoros package, which is its entire job in the kernel. It takes the response that gets sent back from the root collection and it emits it, which hopefully works. I'm requiring an emitter interface here, which is an interface. So in the container, rather than creating a whole entry and return new whatever, I can just bind anything looking for this interface to create a instance of this concrete class. So that saves about 3 lines of code. In my action then, instead of echoing out what the template engine renders, I insert that into a HTML response that I create. I return that, and then the emitter emits it, and hopefully it all still works the same way. So I'm after doing all that work to make sure that the application can handle multiple routes, so I'm going to create a second route. Here's the action for it. This time I'm going to get multiple rows, and I'm going to render them in a different template. Back in the service provider, here's my second route going in. It's going to be at /historic, and that's the name of the new action. Here's what it looks like. It almost looks like a real web application at this point. This is where it's going to start to pay off. I want to take that new action I made and password protect it. I want to make it that administration function that I talked about at the start. And so even doing something as straightforward as HTTP basic auth by myself is going to be a pain in the ass. So instead, I go onto Packagist, I type in basic auth middleware, and in about 30 seconds I find some package. I didn't write the name down. I didn't put a use in, so I don't even know what it's called. But I create an instance here and configure it. This is a new library. Configure it secure or false because this is a demo. I don't need it to run an SSL. Users, these are the people that can enter it. Again, I don't want sensitive credentials in version control, so I'm going to use environment variables, create some new ones for a user and their password. Then all I have to do is go back to the route I just created and run a middleware function on it, pass that in, and it works. It just works now. That was all I needed to do. So thanks to using PSR7 as my implementation, or sorry, a PSR7 implementation, making my actions all compatible with that routing library I used, using envars earlier and setting up .env for that. I put this together in about 3 minutes, and I understand completely how it works. It's not something I read in a manual on a website, and I pressed F5 and was happy that it worked. I know why this works, and I'm very happy about it. You may be wondering if you've used frameworks where the root.php file is. I haven't created one yet, but I can very easily. I can go back to where I was defining all my routes in the service provider and then just include a routes file. Extract them out there, throw in the namespace so I don't have to do these as all fully qualified. And yeah, then you have the roots.php that looks similar enough to anything you'd find in a framework. So the application is done for tonight. Maybe I'll go back to it, who knows. This is composer.json now that I'm done after running 12 require statements on it and getting packages from 11 different package authors. That's a lot of code in the vendor directory that I didn't write. Most of the code I wrote was glue, structure, stuff kind of looking to the future to make sure that it would all still work sensibly. It's maybe 500 lines of code in this demo. Most of that is white space or brackets sitting on a single line. It's very little business logic, mostly down to the fact that this is a demo, so it's just kind of a trivial application. But even still, you'd be able to pull that out a little bit from the application infrastructure, user interface logic, and really isolate it if you want without adding any more functionality to this. So with no framework, I built a very simple application that does all this. It does exactly what I wanted to do and no more. It's structured exactly the way I like it to be. And if you get the opportunity ever at work, try do it at work, because you get paid for it, or do it for fun at home. Try doing this. If you were going to use, like, you know, Slim or Silex before it goes away, or that Laravel micro framework, maybe don't use a micro framework. Maybe just don't use a framework. See how you get on. If you only have one route to call, don't bother setting up a router. Just put an action directly in the index file. Just try it. You'll learn something, and someone might give out to you at work, but just ignore them. They'll go away eventually. Thanks. Any questions?